Welcome back. Today we're going to cover two-dimensional arrays. The reason that two-dimensional arrays are so important is because many of the things that we wish to represent when we're programming are two-dimensional or multidimensional, in fact. For instance, any table of data that we'd wish to hold or games that are played on grids. In this example, we see the game of tic-tac-toe. So tic-tac-toe is a game that's played on a 3x3 grid where players take turns placing X's and O's on the board. The first player to get 3 in a row wins. If you haven't played, you should try. So the question would be, how do we represent something even as simple as tic-tac-toe in Java? Enter two-dimensional arrays. Multi-dimensional arrays are useful for representing grids or other multi-dimensional tables. So we can also look to three-dimensional grids. For instance, if you wanted to represent a Rubik's Cube and how one could solve that, you would have to move to a three-dimensional model. So multi-dimensional arrays are declared and instantiated in a similar fashion to how we handled one-dimensional arrays. In order to declare the multi-dimensional array, we first give it the type. In this case, we're looking at a tic-tac-toe board. We're going to hold letters, and so we'll give it a type string. Following that, you'll see square brackets, just as we saw with one-dimensional arrays, except this time you can see there are two, and that's because we want to create a two-dimensional array. So there's one set of square brackets for each dimension. If we had a three-dimensional array, we'd have 3 sets of square brackets. Following this is the name, and that's the declaration. To instantiate this, what we want to use is the new operator, just as we did before. Then we give it the type, and again, we have those square brackets with the dimension, the size of the dimension included. So in this case, we want a 3x3 grid, and so we give the first dimension as 3 and the second as 3 as well. All of this looks very familiar, except for the fact that we have that extra set of square brackets and that extra dimension at the end. So we'll see what that looks like in terms of what it's actually producing. So multidimensional arrays are really represented by an array of arrays. So you can imagine that you're creating a string array of size 3, and then within each one of those, you have another three-dimensional array. So this depiction here is of our little board in red. So you can see our board in red writing with a clear winner across the diagonal is represented as follows. So in this case, the first dimension, if we were creating a one-dimensional array, we would have just the rows, but then the second dimension is going to give us each of those columns that we wish to hold. So let's consider a problem where we have a tic-tac-toe board and it's set up as a two-dimensional string array named board, and we're given an integer which defines the row, and an integer which defines the column that we want to play. So when you play tic-tac-toe, you start with this 3x3 grid, and when it's your turn, you decide if there's space. And if there's space for you to play, you can place your letter. So in this case, we want to place the letter X. So if we're going to model a tic-tac-toe board with a two-dimensional array, we have to go first see if there's space for us to play. If there is space for us to play, then we want to place our X in that position. So we decide which row and column we want to try, we check if it's free, and we place the X there. So given a two-dimensional array board and the row and column that we'd like to play on, challenge yourself to output a Boolean value, true or false, depending on whether or not there's space to play the X. So here's a potential solution for this problem. So we assume that there's this two-dimensional string array named board. And recall that when a string array is instantiated, the values that are initially held in each cell of that a grid that's been created, each element in the array is set to null. Okay, so if something's empty at this point, it's holding a null value, which is important because what we're looking for is an empty element within our array. So then we're given an integer row and column, and this defines the row and the column that we're going to look within our two-dimensional array. So now we've set a Boolean variable can play. We'll set it initially equal to false, meaning we assume that we can't play there. We assume that that position within our tic-tac-toe board is already taken. And then if we find that it's empty, we can flip that switch to true. We'll set can play to true, letting us know that we're allowed to play there. Okay, so the condition that we're checking for is if within our two-dimensional array board, what we find within the given row and the given column is null. So the one thing that we have to be careful of is that while we've been given a row number and a column number, they don't necessarily align with the index of the row and column within the two-dimensional array. And in fact, they're off by one. Remember that, like, I would think of the first row as row 1, and all users would. But behind the scenes, within the array, our index starts from 0. So if we want to look for a row, the index number that we're looking at is row -1. The same is true with column. If we're looking for a given column, the index number of that column is column number -1. And so in this case, what we want to check is whether or not board at index row -1 and column col -1 is equal to null. And this is a funny piece because you know that this is a string array, but in this case, we're actually looking for equality. And so we're actually looking for, because null is not a string, we're actually looking for whether or not the contents of that board at that specific set of indices is equal to null. So then we said, if we find that what's held there is null, then we can set it equal to x, and we can flip our Boolean switch from false to true. So we set can play to true. And at the very end, we were asked to output whether or not we could play, and so we system.out.println can play. And that's it. Thanks for learning.
Wait, are we done already?
Yes. Why?
I thought we could stay for a while. Get it? For a while?
I don't get it.
Are you loopy?
Maybe I am. Next time, we'll cover loops, the while loop and the for loop. I guess you get it. See you next time. Image sources for this particular video are from Wikimedia Commons and the Creative Commons public domain.